Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to take a look at Google's services for big data and the Internet of Things. Now before we jump into any particular service, let's take a look at big data as a whole. So this breakdown is from Google's page on the data lifecycle. Now different people decide to break the data lifecycle down in different ways, but I think Google's perspective is a valuable one to consider. They say that there are 4 different stages: ingest, store, process and analyze, and then explore and visualize. So the first stage, ingest, is to pull the raw data in. Maybe it's streaming data from different devices, or batch data from on-premises systems, or application logs, or maybe user events and analytics from a mobile app. Somehow or another, there's a lot of data, and it comes into the system. So after all that data comes in, you need to store it somewhere where you won't lose it, and somewhere that makes it easier to access it. After that, the next stage is to process and analyze the data, to transform that raw data into some actionable information. And then in the end, the final stage is to turn the results of that analysis into something that's valuable for your business, something you can use to make better decisions and share with others. Now this is really a huge oversimplification, and many other presentations of this life cycle split apart the process and analyze, and they might have multiple different storage phases and a lot of feedback between them. But this is just an idealized view. Also, because many of these services are covered in other lectures, I won't go through all of them in this particular one. For example, I've covered all of the storage services in a separate lecture. In this lecture, we'll go through the services that are more specifically big data and don't fall into one of the other categories. Alright, so let's start where some data gets created. Google's Cloud IoT Core service is a fully managed service to connect, manage, and ingest data from Internet of Things devices globally. This compares to AWS's IoT service, which has a number of similar features. Or maybe you'd build your own custom management system. Now let's take a look at this service in the context of a specific architecture. So here's the Cloud IoT Core service, and it handles all the communication with the devices specifically, giving them new configuration and accepting all of their telemetry data. You can also see how this connects through to Cloud PubSub to send data along, and updated device configuration can be sent in from other systems too. Now the Device Manager part of Cloud IoT Core handles the device identity, authentication, configuration, and control, and the Protocol Bridge piece publishes the incoming telemetry data to Cloud PubSub for processing. This service can handle connecting to devices using the industry standard protocols MQTT or HTTPS. A nice feature of Cloud IoT Core is that you can verify device ownership on the first connect using certificate authority signed certificates. You don't just accept incoming data from any device, you have a way to make sure, in a completely automatic way, that it's one of your devices. Now that's pretty normal for an IoT system, but the nice thing about this feature is that you don't have to do this by loading every individual device into the Cloud IoT Core. You can send devices out with bulk generated certificates on them and then register them when they come online. So since IoT Core has two-way device communication, that means you can update the devices with new configuration or firmware. And the service has a way for you to do this even when the devices are offline. You can query for information about the devices based on their last seen information and make control changes that'll be applied when they come back online. Now, there's no per device charge for this service. You just pay based on how much data you exchange with the different devices. So like we saw from the IoT system diagram, a likely place to send big data is Cloud PubSub. Now PubSub stands for Publish Subscribe, and this is an infinitely scalable, at least once messaging service for ingestion of data, decoupling of systems, and so on. Use cases for this service include balancing workloads in network clusters, implementing asynchronous workflows, logging to multiple systems, and data streaming from different devices. It's also been described as a shock absorber that lets you weather outages and frees you up from having to scale every piece of your system in lockstep. This is one of the most important services in GCP because it's the glue that links everything else together. In the same way that Google Cloud Storage can help large blobs flow through a system, Cloud PubSub can help all manner of smaller data flow. The way Cloud PubSub works is that you have a topic, and then a publisher sends a message to that topic, which will then get sent to all of that topic's subscribers. A nice thing about this fan out to multiple subscribers for the same topic is that you can even add subscribers later without affecting any part of the existing system. And so in that way, it can actually buy your system some agility or adaptability to change. So in the Amazon world, PubSub is handled by Amazon SNS, the simple notification service, where all published messages get pushed to the listening subscribers. But Cloud PubSub also has a poll mode that's a lot more like Amazon SQS, their simple queue service. And from that perspective, the on-your-own way of doing this might be to use RabbitMQ. But Cloud PubSub handles more use cases than that, and you might find that it winds up replacing Amazon Kinesis or Apache Kafka in your architecture. Now, Cloud PubSub doesn't support subscribers rereading their streams like Kinesis and Kafka do, but there is an open source Apache Kafka connector that can republish Kafka messages to Cloud PubSub and vice versa. Unlike a lot of services you might compare this to, Cloud PubSub is global by default. You can publish from anywhere in the world and consume from anywhere with consistent latency and not having to deal with any replication yourself. Cloud PubSub is based on GCP's HTTPS load balancer, and it'll direct incoming requests to the best region to minimize latency, while still handling any region imbalanced publishing and subscription that might happen. Messages in Cloud PubSub can be up to 10 megabytes in size, and this is quite large in comparison to other services. Also, if a message is undelivered, it'll be stored automatically for up to 7 days, but unfortunately there's no dead letter queue to catch poison pill messages that have a hard time being delivered. Cloud PubSub's push mode will deliver to HTTPS endpoints, and it'll succeed and delete the message when it gets an HTTP success status code returned. Push mode uses a slow start algorithm so as not to overwhelm the receivers. This will ramp up and send more messages at a time every time there's a success, and it'll back off and send fewer messages if it encounters a failure. While push mode sends messages as soon as they're received, pull mode will hold on to messages and deliver them when clients request them instead. When a client asks for a message in pull mode, that message is hidden from other clients until the client that got that message acknowledges it and says that the message is okay to delete, or until the timer expires. Pull mode can be good to let clients set how quickly they want to consume messages, and it can also let clients grab a bunch of messages at a time. One other thing to call out is long polling, which lets a client call out to Cloud PubSub and wait with the connection open until a message appears in the queue, and then it goes directly to that client quickly. That can help you get lower latency without having to open up an HTTPS endpoint. When you use Cloud PubSub, you pay for the data volume. Each publish, push, or pull request is charged at a minimum of 1 kilobyte. So once you've ingested and stored a bunch of data, what do you do next? Well, Cloud Data Prep is a tool to let you visually explore, clean, and prepare data for analysis without running servers. So with a description like that, you'd probably think that this tool competes with the likes of AWS Glue and Informatica Power Center because it's an ETL system, extract, transform, and load. And you wouldn't be completely wrong there, but you would be mostly wrong. And that's because this is more of a data wrangling tool for business analysts, not really for IT pros. These are people who might otherwise spend up to 80% of their time just cleaning data, getting it ready so they can use it. And from that perspective, this is in the same class as OpenRefine and actually competes more directly with a tool like MATLAB or even Excel. What this actually is, though, is it's a managed version of Trifacta Wrangler. And unlike most of the other services in GCP, this service is not managed by Google, it's managed by Trifacta. This tool can source its data from Google Cloud Storage, BigQuery, or you can upload files directly, and the data could be formatted as comma-separated values, JSON, or relational. This tool automatically detects schemas, data types, possible joins, and various anomalies, such as missing values, outliers, and duplicates. And behind the scenes, it uses machine learning to suggest transformations. When you use this tool, you pay for the underlying data flow job that gets generated, plus a management overhead charge. And you'll also pay for any services you access, like Google Cloud Storage or BigQuery. So let's say that you've gotten your data ready and you want to process it now. Let's take a look at Cloud Dataproc. Cloud Dataproc is batch MapReduce processing via configurable, managed Spark and Hadoop clusters. This is a lot like Amazon's Elastic MapReduce service, or you might set up your own Spark or Hadoop clusters. Now you can tell Cloud Dataproc to add or remove nodes even while it's running jobs, and it's integrated with Cloud Storage, BigQuery, Bigtable, and some Stackdriver services too. Its image versioning feature lets you switch between different versions of Spark and Hadoop and other tools, and when you use Cloud Dataproc, you pay directly for the underlying Google Compute Engine servers that are used in your cluster. To save money, you can make some or most of these preemptible, although you'll always need at least one node that's not preemptible. You'll also pay a time-based Cloud Dataproc management fee that depends entirely on how many virtual CPUs you've got in the cluster. Now, Cloud Dataproc is best for moving existing Spark or Hadoop setups to GCP. If you're building a new data processing pipeline, you should really prefer Cloud Dataflow instead. Go with the flow, as they say. And that, of course, brings us to Cloud Dataflow. Now, in 2014, Google's Senior Vice President of Technical Infrastructure, Urs Hölzel, said, "We don't really use MapReduce anymore." Now, this was a little bit of hyperbole, but the point is still there. Plain MapReduce or Hadoop are the old way, and there's now a better one. So Cloud Data Flow is a smartly auto-scaled and fully managed batch or stream MapReduce-like processing system. Cloud Data Flow lets you unify your batch and stream processing, and it's automatically scaled in some really awesome ways. Now, you definitely might choose to build an ETL pipeline around Cloud Data Flow instead of a specific ETL tool like Informatica PowerCenter or AWS Glue. But Cloud Data Flow is a really general purpose tool too, and because it does MapReduce-like processing, this would be compared to Amazon's Elastic MapReduce service, or you might set up your own Hadoop or Spark cluster. But there's one more thing to consider here, and that's Apache Beam. Google has released a version of Cloud Data Flow as the open source Apache Beam project, so you could look at using that if you wanted to do it on your own. Cloud Data Flow auto-scales and dynamically redistributes lagging work so that it can optimize the total runtime. It'll reshard the data mid-job. The service is also integrated with Cloud PubSub, Data Store, BigQuery, Bigtable, Cloud Machine Learning, Stackdriver, and other stuff. This is a very central service. A lot of things connect with Cloud Data Flow. For performance and potentially cost gains in batch runs, the Dataflow Shuffle service can offload the shuffle operations from the workers. In some cases, this can give a 5 times improvement in performance. Now with Cloud Data Flow, you don't see a line item for the Google Compute Engine instances underneath it, but you are paying a time-based charge for the provisioning of virtual CPUs, RAM, and different persistent disks, and these charges are higher in streaming mode. If you use Dataflow Shuffle, you're also charged by time per gigabyte of memory that's used, but this is something you'll have to compare to the reduced cluster size you can wind up using. Alright, after you've processed a bunch of data and presumably stored it in something like BigQuery, you might use Cloud Data Lab, which is an interactive tool for data exploration, analysis, visualization, and machine learning. This uses Jupyter Notebook, and that's what you would set up if you were doing this on your own. If you're not familiar with Jupyter Notebook, or IPython as it used to be called, this is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. Uses include data cleaning and transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more, they say. This tool can support iterative development of data analysis algorithms in Python, SQL, and JavaScript for BigQuery user-defined functions. When you use Cloud Data Lab, you pay for the instance that's hosting and storing your notebooks, and you'll also pay for any other resources that you wind up accessing, like BigQuery. But in the end, your data will almost certainly need to make its way into some dashboards and reports, and that's where Cloud Data Studio comes in. This is a big data visualization tool for dashboards and reporting. You'd compare this to Amazon QuickSight or something like Tableau. It's important to have meaningful data stories and presentations because then business decision makers can make better decisions. Cloud Data Studio can get data from a lot of different places, including BigQuery, Cloud SQL, other MySQL instances, or even a Google spreadsheet, and it has a bunch of different visualizations so you can present information really effectively. You can get started quickly with some of the templates, and then you can customize almost everything to make sure that it's just right. You can even collaborate in real time with Cloud Data Studio, and you share things in the same way as any other G Suite document. Cloud Data Studio doesn't have a charge for itself, you pay only for the services that you wind up accessing. One more big data service to look at is Cloud Genomics. This is a service to store and process genomes and related experiments. Behind the scenes, it scales in a way similar to how BigQuery does, so you can query complete genomic information of a large research project in just seconds, and you can deal with lots of different genomes and experiments in parallel. Cloud Genomics uses open industry standards, like the ones from Global Alliance for Genomics and Health, so if you were doing this on your own, you might use the Genomic Data Toolkit from that group. One thing to call out is that Cloud Genomics supports the requester pays sharing model, which means that you can host the data and only pay for the storage of it and share it with other researchers, and then they'll pay the charges associated with their use of it. Well, that wraps up our look at GCP's specifically big data services, so if you have any questions for me, please let me know. If not, please feel free to move on to the next lecture. Thank you.